Hello, Dr. Ron Eaglin here, and today this is programming for engineers with Python, EGN 3214, and today we get to have a lot of fun because we're going to talk about object-oriented programming. And object-oriented programming is really just a way of organizing your programming and your code better so that you can actually reuse the code in many situations. Also, if you've got very large projects, they tend to get unwieldy. And object-oriented programming and the ability to create classes and class methods makes it much, much more simple to organize your code. So we're going to jump right into this. So the first thing I'm going to do is I'm going to jump right over here to the code. And first I'm going to talk a little bit about the abstraction that we're doing here. The abstraction that we're doing here is we're coming up with this concept of a shape. And I'm going to program this. And an example of shapes would be, let's say, circles and squares. And that's the example I'm going to use. And I think that if you really think about it a lot, you can think about all sorts of things that can be abstracted at different levels. Like you can say a vehicle. Well, a vehicle could be a car or a truck. Or you can go one step further. You can say conveyance could be a car, a truck, or a boat, or a plane. And you take those things that are common to all of those and you abstract those down to the lowest level. And then you inherit that capability forward in each of the different things that inherits from it. So that's kind of easy to see in this concept of shapes. So what I'm going to do in Python, the ability to create an object, and what we're doing here is we're actually creating the definition of what an object is. So in other words, I'm going to define a class right here called shape. And inside the shape, I'm going to have two functions. Now, functions inside of classes are called methods. Sometimes you call them class methods, but I typically just say they're methods. But when I say method, I'm talking about a function that belongs to a class. Now, one of these methods is the default method, which is underscore underscore init, I-N-I-T, underscore underscore. That is a specific method that lets you create that class. So there's not a whole lot to it. We're not actually even going to use it in this case, but you can see I'm going to actually use one in one of the inherited classes below it, but that's also called a constructor. But it's basically a method that lets you create an instance of the class. I know that's a lot of weird words, but they're actually important. An instance of a class. And you'll see that in just a few minutes. So there's two methods. Remember what a method is. It's a function that belongs to a class, init and printArea. And the printArea of this class shape returns a string, which is essentially going to be a string that says shape colon, and then it's got a place for the name, and then area colon, and then it's got a place for the actual area, which we're going to calculate. So in this situation, the shape class is actually going to be what we call an abstract class. In other words, we don't make a shape directly. We've got some classes that we're going to inherit from shape that we're actually going to use to make real shapes. Because shape is really not, there's no shape to a shape. So let's now create this class, another class called circle. And in this parentheses right here, you can see that we actually take the definition of shape and we put it in here. What this means is that the circle class is going to inherit from the shape class. So everything that belongs to the shape class also belongs to the circle class. But in circle, we're going to define another constructor method. Remember, a constructor method, which in the case of Python, is already predefined to have the name underscore underscore init underscore underscore. Now it has two arguments. Now, methods in Python, or what we can call them class functions. Methods in Python, the first argument is always self, and then the second argument is diameter. And there's a reason why that first argument being self is very, very handy. Because if I create an instance of a circle, then I need to be able to access the parameters of the instance of that circle, and the self allows me to do that. Now, here's what I'm going to do here. Inside this init function, I'm going to have a property. And a property is a variable that lives inside of a class. Okay, so I said that a function that lives inside of a class is a method, And a property is a variable that lives inside of a class. We call them properties and methods. That way they have their own specific name. We have a way of knowing when I say a method or I say a property, you know that those variables or those functions belong to a class. So I'm going to set the self.diameter equal to the diameter. What this is doing is it's taking the diameter that's passed to it and it's setting the property diameter to be equal to the diameter that was passed. These are not the same thing. This diameter and this diameter are not the same thing. Also, if you look back at the abstract class that is the parent of circle, and we do use the term parent and child because we do say that they inherit. Okay, in the parent of circle, which is shape, we have this thing called the name, which is a property name, and we can set the name because remember, circle inherits everything that shape has. So if shape has a name, circle has a name, and we actually set that name equal to circle. And then we actually now are going to define a function called area. And we can because in the case of a circle, we can calculate the area. So it returns pi d over 2 quantity d over 2, which is r, pi r squared. Math pow is r squared. Wow. So it's got the ability to calculate an area. Well, this doesn't actually mean a whole lot until I can go one step further and create another class that inherits from shape. This time we'll do a square. And we're looking at the same thing. Square inherits from shape. It's got a constructor method that you pass the length to. The length property, the length that's passed to it is set to the length property of the square. The name property is set to square, which is the inherited property from shape. And we have to define a second function called, or second method called area, which in this case returns the length squared. Now comes the power of this. Let's instantiate a class. When we say we instantiate, it means we make an instance of a class. So this, first let's take all this code right here and let's bring it in. Okay, so now everything in there is now been compiled into Spider, and we can go up a little bit here and I can now create an instance of a circle. So if I take this, my circle, well actually I'm going to do both of them because you might as well see the print area. My circle is equal to circle 5. What that does is it creates a variable that is an object called my circle that is of class circle, and if you recall, you pass over the diameter with the diameter 5. So if I hit Control Enter, and now I look down here, you can see that my circle print area printed out shape, colon, circle, area. Let's see, I can probably bring this up so you can see it a little bit better. My circle, shape, colon, circle, shape, colon, circle, area, colon, and then the area. Well, if you look over here back at where we actually had the print area, there was the shape and the area. It's what you told it to do. And notice, very important notice, to access the method of the class that we had defined, print area, we use dot notation. So we create an instance of class circle with a diameter 5, which is what this init right here does. Then we take my circle, which is now defined in dot print area. It calls the method of the circle that you created, which then prints out the area with the properties that you had set. Okay, realizing that print area is in the abstract class shape, which the class circle inherited. Now, of course, because I can do this, I can now do this with multiple circles. I can, in other words, create more than one circle. I can create a second circle. And notice over here that that circle actually has an output. And again, I can do the same thing. Now that I've created a circle, I've also create a square. Control Enter that guy right there. And as you notice, I've now got my square, square 10, my square print area, and the shape this time is square with an area of 100. Well, why? Because when I initialized the square, I set the length equal to the length that was passed over, which in this case was 10, and the name was square, so my print does that. Now, a few things. I'm just going to show you one more thing that will be very, very useful to you. Now, of course, you can always use the Control-I to get to this information. Put the cursor on the object you want to look at and hit Control-I. But I also want to show you that there's some nice built-in functions here. Print mysquare dot underscore underscore dict dictionary. It's the dictionary. Underscore underscore. That's a predefined function. And what it's going to do is it's going to show you the current properties of the instance of the square, which is the object my square. The object my square is an instance of class square with the properties of length and name, which have these values. So it will show me the properties of the instance of the square, or in other words, it'll show you the properties of the object my square. Every word I said there is important. They actually is the way that you've got to talk as a programming. This is to understand what things are. So the language is actually very precise. I'm also able to show the dictionary of the class. So if I go over here and say print square, Control Enter, now here it's going to show that there's this thing underscore underscore module underscore underscore, which has the value of underscore underscore main underscore underscore. Also init. Okay, remember we made the function or the method init. Well, it's a function, and it shows you where it actually lives in memory. And the function area is a function, and it has a location it lives in memory. So you can see the properties of the class, which is the definition of a square, and it shows also you can show the properties of an object, which is the instantiation of the class with actual specific values. So I did all that. Hopefully there's a lot of language right here to learn, and I know it's almost overwhelming. But in a nutshell, that is the important part of object-oriented programming. The last piece is why. Why is because, why do you do this? Because it makes organizing your code much better, and it makes for much cleaner and easier to read code. And realize that many code projects can run into hundreds and hundreds of thousands of lines of code. So your ability to organize is extremely important. And this is the best way that we have found, really, to organize and define and write code. Thank you very much. Hope that you enjoy a little bit of programming. I'm going to give you a little bit more on object-oriented programming because you're going to use it to solve real problems soon. Thank you. Good programming.